Okay, we are just covering the first module, first paragraph of the first module, where they have mentioned about the elementary concepts of the DC circuits. Where, because we are meeting after a little interval, we went through the basic terminologies: voltage, current, power, resistance, EMF, resistances in series, resistances in parallel, current and voltage division rules. Capacitors, inductors were not introduced till now. Capacitors and inductors we'll look into in a later stage. Okay, we'll come to that later. Now, because we are concerned with DC electric circuits, rather difficult to bring in capacitors and inductors now. Then the VI relations and energy stored, etc. That will come in a later stage. Then Ohm's law, Kirchhoff's laws, problems on that, star delta, and the last one is star delta conversion. That is what we are going to do now. Today in today's class, it's clearly written. It is for resistive networks only. Derivation not required. Only the problems are required. By the way, I have given you an assignment. I have uploaded an assignment in the classroom. Submission date is also given. Wherein one problem is based on this. Okay. All the others have been explained and notes have also been uploaded. Just go through the class videos as well as the notes that are given, and do your assignments. And one thing that I can tell you is, first 10 students do their assignments, and then if possible, you make a Google Meet by yourself. 1 to 10 number, roll number 1 to 10. From 11 to 20, another set of students can do. After completing your assignments, you can have a discussion session, and then that will be much more clear. After which you have to upload the assignment. That's what my plan is. Okay. Now we'll go directly into the star delta conversion. Okay. Okay. This is where we had stopped earlier, wherein we were thinking about parallel circuits, etc., and effective resistance. Now, there are situations where the network will be a tangled network, like what you have in your head, tangled here. There, the resistors may not be parallel. They need not be connected in series. There can be other situations where other kinds of connections are there. So, to make those connections or those to bring in an effective or an equivalent resistance for those, to find out the equivalent resistance for those kinds of circuits, we use something known as star delta conversion. Star delta conversion, or back delta to star conversion. Now, for example, if you consider a bridge circuit like this, you might have come across bridge circuits. You know, these kind of bridge circuits where you can have resistors like this. There can be resistors connected like this and all those things. And there may be a voltage source, or it may be required to find out the R effective in this case. You cannot say that this resistance and this resistance, R1 and R2, are in series because of this resistor here. And also R4, R5, they are not parallel. So, or you cannot say they are in series also. This R and this R1 are not in series because of this kind of a division here. So in such conditions, instead of having two terminals, there may be required, you may be required to make a conversion to a three-terminal connection. Three-terminal. Usually, we say that it is a star delta conversion. I hope I'm sure you know all these things. Yet, for my relief, I'm talking about this. It can be a Y connection, which is like a star, or the same is it is the same as T connection, which you denote by T, because this is like Y connection is like, it's a star connection. It will be like this: R1, R2, R3. The same network, sometimes it will be misleading for very fundamental, maybe for first year students. This is also a star connection. Okay, R1, R2, R3. This we name as star connection. Y connection, star connection, or T connection. This is the same as this because this point I just put it in this form. Okay, this is the star point. So in any network, you see such a kind of connection, or which is straightened out like this. This is a star connection. Okay, you can have another kind which is called as a delta. Delta, which is the same as pi. This. That network. That will be looking like, this delta can be in any shape. I am just drawing this like RA, RB, RC. Same. Pi means you will have RA like this, RB hanging like this, RC also hanging like this, and you have this RB, RC. This is also the same network. Don't get misled as to this is not, sometimes there may be a case where delta will not be like this. Delta will be straightened out like this in the shape of a pi. They are the same. Okay. Now, in the syllabus, they have mentioned that you should learn about how a star-connected network can be converted to delta and back also. And the derivation is not required, specifically said. Thank God. So let's first start with delta to star connection. Conversion. Star is the same as Y. It's the same as T. So if I draw a delta, you want to change from delta to star. So if I have an only resistive network, so all resistors. Okay. So let me write this as RA, RB, RC. I want to convert this into, this is node A, this is node B, this is node C. I want to convert this into star. Okay. I want to convert this into a star network. Always remember, whatever I have drawn is not that I have drawn some other more resistors. I want to replace RA, RB, RC with okay, RA and RB, okay. With resistors R1, R2 and R3. That is now across the, or to the points A, B and C, I should have a star instead of a delta, which this is R3, this is R1, any number, you can number it in any manner. I'm just putting it like this, that's all. Okay. So instead of RA, RB and RC, I want to convert this into this, so that at the terminal A, one resistance will be connected, R3, at the top terminal B, R1 will be connected, and the terminal C, R2 will be connected. How do I make the conversion? As I told you, there is no derivation. Derivation is not required. So R1, this R1 is equal to RB, RC by RA plus RB plus RC. How did I take RB, RC? And when I calculate the value of R1, I take this and this resistance. R1 is enclosed within these two resistors. So RB and RC. Okay. If so, R2 will be, R2 is this, which are the resistors enclosing which are the resistors on the two sides of R2, RA and RC. RC, RA. In a cycle, if I write it in a cyclic manner, it will be RCRA. You can write it either way, RARC also. RCRA by RA plus RB plus RC. Similarly, R3. If I write R3, R3 is equal to, which are the resistors on either sides of R3? RA and RB. So I write it like that. RA, RB by RA plus RB plus RC. Or in short, what you have to find, what you have to remember is when you convert from delta to star, each resistor will be equal to the product of the resistors on either side of that resistor divided by sum of all the three resistors in the delta. I'll repeat that once again. When you convert a network from a delta to star, any resistance that is connected to a terminal, any resistance in the star connection, say R1, which is connected to the terminal, will be equal to, or can be calculated as to be equal to the product of the resistors on either side. Always remember, they are protecting them. So product of the resistors on either side divided by sum of all these resistances. That is how you convert from delta to star. Now, star to delta. Conversion from star to delta. Okay, let me, so which means I have a star network like this, where I have R1, R2, R3 connected on three terminals. That was what I said earlier, three terminals, B, C, which I have to convert to delta. Okay, again the terminals remain as A, B, C. Now I can even write this as RAB, RBC, RCA. Or you can put it as RA, RB, RC. Anyway, which means RAB is the resistance which is connected across these two terminals. How do I find that? Again, you don't require the, you don't require the derivation. So for easiness sake, let me draw this inside, okay, so that you will find it easier to understand. So this is R3, this is R1, this is R2. So RAB or RAB is equal to R1 R2 plus R2 R3 plus R3 R1 divided by you are writing RA, okay, or RAB divided by whatever resistance is opposite to that. When you are mentioning about RAB, you will be thinking about this resistance. So that will be by divided by R2. Okay. Similarly, if I am thinking about RBC will be again R1 R2 plus R2 R3 plus R3 R1 divided by whatever resistance is opposite to it, that is here R3. So I'll be writing R3. Last one, RCA, that you should know by now. RCA will be R1 R2 plus R2 R3 plus R3 R1 divided by R1. Is that so? So just remember these equations, not by heart, but you should know. When you convert from this star to delta, what happens is you put all the sum of the products of two resistance divided by the resistor which is opposite to that arm of the delta. Okay, so let's do a problem. I have given you assignment on this section also. Please try. Okay, I'll give you a problem now. Let's think about how to do this problem. we'll go very slowly. Obtain the equivalent resistance for the given circuit. Please write down. Obtain the equivalent resistance for the given circuit and find I. And the find current I, use star delta transformation method. Why specifically this method? Because we have learned this method now. Or else there are many other methods by which the same answer can be found out. That is the beauty of electrical engineering. The network that is given to you, it is up to you to solve in whichever way is easier. So usually, after learning many methods, if you are really interested, you will understand which method is easier to solve which problem or a specific problem. That is where your talent will lie. Okay. So in this problem, it is specifically given that you should use star delta transformation. Now draw the circuit. Okay. This is 12.5 ohm. 12.5 ohm. 15 ohm. 5 ohm. 10 ohm. 20 ohm. 30 ohm. Now that 12.5 was given in a book as 12.5, so I took it as 12.5, so that the answer will be as given in the textbook. That's all. Okay. I could have taken test 12 also, but okay. Let this be A, let this be terminal B. Now you are asked to find out this current I. Now to find out that current I, you are given the source voltage is 120. So if you can find out the total equivalent resistance of this R equivalent, then I will be nothing but I is equal to 120 divided by R equivalent, isn't it? So you are asked to find out the R equivalent. R equivalent can be found out in many ways, or I can also be found out in many ways. But you are specifically asked to find out using star delta conversion method. So let's try that. Okay, this is the current. Can you identify star or delta in this circuit? Anyone? Oh, let me put some terminals also. These are all terminals A, and these are all terminals B. So I can put C as this terminal, this node, and this as D. Okay. Can you identify any star or delta connection here? I'll call out someone. Vismaya? Vismaya. Vismaya is here. Where is Vismaya? Let me see. Every day I call and then no one. Vismaya, where are you? Vismaya is attending, but she's attending virtually. Vismaya? Yeah. You don't have a mic? Yeah. Don't you have a mic? I feel like laughing sometimes, like you may be telling the truth, but there are lots of trolls on this, So sometimes I feel that I am also being trolled upon. Okay. Okay, so so if you look at this, there are many Y circuits and there are many, the delta also. If you look at this is, oh, sorry. What did I? Okay, if you look at this is a delta, this is again a delta. So delta, there are many. More than this, I have just put two deltas. Then you have, this is a star. Okay, by this much is a star, or I can even consider this much as a star, 5, 12.5 and 15 ohm, or 5, 10 and 20 ohm. So anyway, you can consider and you can change or you can convert. So let me do one thing. What I'll do is, it is not necessary that you follow the same way, but let me think about this. Step 1. Okay. Step 1. Or let us do it together. In the next problem, which is given as an assignment, you can do yourself and try. Step 1. I'll consider 5 ohm, 10 ohm and 20 ohm. 5 ohm, 10 ohm and 20 ohm. 5 ohm, 10 ohm and 20 ohm. They are in star. I'm going to convert them into delta, which means I have to convert that into delta so that my circuit now should look like this. Okay. I'm not drawing the voltage source. I'll just start from A and B. Okay. My circuit will look like this. 12 point. Let me see. A, B, 12.5 ohm, 15 ohm. Then here I have 30 ohm. And in here I will have, not here, sorry, not there. This point, okay. Okay. I can connect it here, but then it will be easier for you to understand like this. That's why. Instead of this 5, 10 and 20, I am going to have this conversion done. Find out, please. Just find out what are the values that I have to write here. That is for making it little more easier to understand. I am drawing this part alone. This part alone. I'm redrawing it here. That is, you are having a 5 ohm and you are having a 10 ohm and you are having a 20 ohm, which is to be replaced by this, this and this. This is your delta. Maybe I have to draw it a little more clearly. Let me try. You are having 5, 20, 5 and 10. Okay, and you are going to replace that by a delta. You are asked to find out this value, and this value. Okay, let me put it as, maybe if it is C, D and this is C, 5 is connected, this is D, this is our D, okay. Are you calculating? I hope you are calculating. How do you convert from delta, star to delta? So suppose I am considering this resistance. Okay, if I am considering this resistance, how do I find? The resistance was like this, okay, which was there. So when I find the value of this resistance, it should be R1 R2 plus R2 R3 plus R3 R1 divided by the opposite resistance. Which is the resistance that is here? This is the 20. This is 10. This is 5. So if I am concerned about this resistance divided by 20. Okay, what is R1, R2, R3, R2, all those things? 5 into 10 plus 10 into 20 plus 20 into 5, that will become 350. 350 by 20, that will become 17.5 ohm, or this resistance is 17.5 ohm. Similarly, what is this value? 350 divided by, we get hardly sometime, 350 divided by whatever resistance is opposite to that, 5. 350 by 5. What is this value? 350 divided by resistance opposite to it is 10, 35. So if I redraw this circuit once again with the values that are there, I'll have this as, okay, 30 ohm. A, B, this is 12.5 ohm, this is 15 ohm, this is my 30 ohm, earlier 30 ohm. Then I have this delta coming in, which is 17.5 ohm. This is how much? 70 ohm, 350 by 2. So 70 ohm. Then I have this delta arm which is coming, that is 35 ohm. Okay. This is how I end up when I convert the star into delta. I hope this is clear. Can anyone respond? Varsha, did you understand? Varsha?
Yes, ma'am. Understood.
Hope you are understanding. Okay, I know the time is very less for me to give you a detailed explanation. Now, how will you convert? Now, look at this. 12.5, these points, 12.5 is connected between these 2 points. 17.5 is also connected between these 2 points, this being the same points, A. So 12.5 is ohm is parallel to 17.5 ohm. Second thing, 15 ohm is connected between these 2 points, isn't it? 35 ohm is also connected